All right, now we're going to look at what happens when we've got a number in front of our quadratic functions. And these are vertical, either stretch or compress, right? So we're pulling it from top to bottom or squeezing down top to bottom, or we could be reflecting across the x-axis, right? So our reflections, remember, this way down to that way. We're not talking about our symmetry line here. We're reflecting directly across that x-axis. Okay? And so we're going to start with our parent function. X squared. Remember, when we plot this, we use our table 0, 0, 1, 1, 2, 4. This is x and x squared. So it sits at the origin, over 1, up 1, over 2, up 1, 2, 3, 4, reflect it back across, and we can just use an f of x. There's our parent function, x squared. Okay. Now we've already addressed this when we were graphing in vertex form, right? That's the same a that was outside parentheses as is here. It's just I've got a 0 in parentheses. And we want to focus on what is this going to do so we have an idea of what's going on. It's still positive, so it still opens up. But we need to figure out how it compares back to x squared. So when we make our table 0, 0, 1, 1, 2, 4, now we're going to multiply by that a value to 8. So I'm still going to my 0, 0 because we haven't moved anywhere. But now we're going to go over 1 and up 2. Over 2 and up 1, 2, 3, 4, 5, 6, 7, 8. When we reflect those across, it's a little easier to see that this parabola is much more narrow. Wow, that is really pointy. Okay, it's much more narrow. Okay, and so we're going to write that down, that it became more narrow than the parent. Okay, so if we had to guess, if I change that to 4, what's going to happen? Well, it's still positive, so it's still opening upwards. When I make my table, if I multiply those by 4, now I'm looking at 0, 4, and 16. So when we plot our points, 0, 0, over 1, up 1, 2, 3, 4, over 2, we're all the way up at 16, 8, 9, 10, 11, 12. It's way up here. Reflect this one across. I know the other one is way high. We're not going to try to draw that high. We're just going to come through here. It's even harder to draw when it's that skinny because it's even more narrow than 2x squared. So the conclusion we can draw from these two is that as a increases, the parabola narrows. Okay, there it's moving faster. It's making bigger jumps from one y value to the next. Looks like the same equation, but now it's a -4. So we know that now this one has turned upside down, and I can catch that with my points because I'm going to multiply by -4. So I still have 0, but now I've got -4 and -16. So when I plot those, at 0, now we're going over 1, but we're going down 4. And reflect that across. And I already know the 16 is not going to fit. So when I draw it, it's the same width, right? It's moving in the same way as our other one that had a 4. It's just going in the opposite direction. And this is what we mean when we say it's reflected across the x-axis. Those parabolas match. They're just moving in opposite directions from each other. Okay? So it's the negative that opens down. Okay? So we said as A increases, the parabola gets more narrow. What happens when it decreases? Because this is the least value A we've had, 1/2. It's positive, so we know it opens upwards. When I set up my table, I still multiply by 1/2. So I get 0, 1/2. 4 times 1/2 is 2. So when I come in here to draw it and I go over 1, I'm only going to come up 1/2. And when I go over 2, I'm only going up 2. Okay. So when we draw this one, it's much wider than our other ones. Okay? This is what we call a vertical compression. Right? If I take my parabola and kind of imagine Play-Doh, right? When you squish it, it spreads out. So it's being compressed from top to bottom, which is what makes this spread out. Okay? So what we're going to look at is, once you're familiar with these transformations, we want to be able to put functions in order. From widest to narrowest. Okay? So if I list these in order from widest to narrowest, so the widest parabola is going to have the smallest A value. So when I look back through my list, it's easy to see in the picture, well, the wide one's the orange one. So if I come back up here, that's H. And then the next widest, when I look at my numbers, remember there's a 1 right here. And so if I'm putting them in order from least to greatest, the 1 is going to come next. That's the gray one, which is right in here. Then f of x. And then if I'm looking at the numbers, then 2 comes next in my graph. We're moving from outside in. There's our pink one, g of x. And since we're only looking at wide and narrow, I'm going to list h and j as the same because they have the same width. They're just moving in different directions. H of x and j of x. All right, we're going to start putting all these transformations together. But these are just the impact that A has on your graph.